Okay, welcome to the second in a series of 4 webinars from the ACM Ethical and Societal Impacts of Generative AI Task Force, which is part of the ACM Education Advisory Committee. Today, we're going to be exploring the ethical and societal impacts of generative AI from a global perspective, and we're excited to welcome 2 guests, Dr. Kutoma Wakunuma, who is Associate Professor of Research and Teaching in Information Systems at Montfort University in the United Kingdom, and Dr. Mehran Sahami, the Tencent Chair of Computer Science Department, and the James and Eleanor Cheeseborough Professor in the School of Engineering at Stanford University. So each panelist will share for about 20 minutes and give more detailed introduction to themselves, and then share about their research and their work in the area of ethical and societal impacts on generative AI. So after about 20 minutes from each of them, then we will also continue with Shaina will be leading the Q&A, and we invite you to put comments in the chat session if you want to follow up from that, and Shaina can use that in the Q&A as well. So let's begin. Dr. Kutoma, if you would like to start off.
Thank you very much, Paul, for your introduction. So yes, my name is Kutoma Wakunuma. I'm Associate Professor at Montfort University. Let me also thank Shaina and everybody else behind this webinar, which I think is going to be an interesting one, where I'm hoping I can learn as much as I'm going to share my perspectives on global perspectives on the ethical and societal impacts of generative AI in education. When I was invited to make this presentation, I wasn't really sure what angle I was going to take. So I'm hoping that whatever I share will be of use to the audience. Let me see if I can. Okay, so the technology is already playing up. We go to the next slide. Okay, so yeah, so I was, I'm going to look at some of the opportunities, and then go on to look at challenges, and then offer some recommendations, after which I'm going to conclude. And I'm sure there will be questions after that. So I'll be very happy to answer these questions. So I'll start by looking at the Secretary, the UN Secretary General, Antonio Guterres' remarks on digital technologies. So he talks about, so he made these remarks at the Council of International Telecommunications Union in Geneva back in June 2024. He talked about digital technologies as reshaping every facet of our lives, but they're also exposing deep inequalities. Bear with me, I need to, okay. But they're also exposing deep inequalities, both within and between our countries. So he goes on to state the fact that for many, the digital promise is still a virtual dream. Today, nearly 1/3 of the world's population remains unconnected, locked out of the digital revolution. The digital divide is depriving billions of people of opportunities, and some of these opportunities, it points to healthcare, job opportunities, and education. And I think this is a good starting point for my contribution, because these remarks cover the fact that technologies such as AI offer a lot of advantages to our everyday lives, but with advantages come disadvantages as well. And one of the advantages, of course, of using digital technologies such as artificial intelligence is, of course, education. And I'm sure you agree with me that education is a human right. We have seen this through several universal declarations or conventions around AI as a human right. So, for instance, the Convention on the Human Rights of the Child states that it's important to recognize the right of a child to education, and with a view to achieving this right progressively and on the basis of equal opportunity. Universal Declaration of Human Rights talks about everyone has the right to education. The African Charter on Human and People's Rights talks about every individual shall have the right to education, just like the World Declaration on Education for All, which underscores the importance of having educational opportunities that are designed to meet basic learning needs. And education then features as one of the UN Sustainable Development Goals, which is goal number 4, which talks about quality education. And within this, we have the element of technology in it, because one of the indicators of meeting this particular SDG is that of use of information and communication technologies. Obviously, the aspect of artificial intelligence doesn't necessarily feature in the Sustainable Development Goals, because at the time that the SDGs were actually formulated, the discussion around artificial intelligence hadn't really blown out as it is now. But of course, we can extrapolate and also relate information and communication technologies to artificial intelligence and its importance in achieving education. And so we can see the importance with which artificial intelligence has in education, because we have, I'm sure, as a lot of us have actually read around how generative AI offers opportunities in education, through, for example, personalized learning. And we have also done research around this. And, a lot of debates and discussions have been had around these opportunities. So, for example, we also have the fact that, generative AI can offer interactivity and engagement, that they can offer self-paced learning, and that there will be some AI tools that can be used to access underserved regions of the world. And there are lots of advantages that we have all come across. So, for instance, there's a lot of discussions around how artificial intelligence can actually help with analysis and ease of identification of patterns in student learning. So with this identification of patterns, it can help with predicting future performance and potential challenges that students can encounter in their education. And because of these predictive patterns, or indeed the analysis or the ease with which we can actually identify the patterns of student learning, we can then have immediate responses to the identified issues, or indeed to the progress that students are making. And so this in itself can enable inclusive education, one might argue, and it can also lead to the bridging of the AI or indeed digital divide. And with the use of these generative AI technologies in education, we can then foster innovation in education. And I think this fostering of innovation can be seen through these analyses or the predictions of these performances and the potential challenges that students face. And with that, then, we can achieve, as certain quarters are meant to believe, fairness, accountability, and monitoring of bias. And so that also helps in terms of collaboration and knowledge sharing. And then we know that AI technologies are also helping with school administration and the data management tasks. So a lot of technologies, a lot of advantages can be gleaned from the use of generative AI. But I'm very much interested in the social and ethical challenges, particularly from a global South perspective, because these advantages may not necessarily be advantages that are felt from less developed countries. And one of the reasons that this it happens is because technology is not neutral. Technology is developed with values and norms and power elements in it. And these can actually result in these social and ethical challenges. We have the values of developers or designers that are inculcated in these generative AI technologies. There are norms that are perhaps different across society. So, for example, what might be private in a country like the UK, or what may be considered privacy, may be different from a country in Africa, for example. And also there are these power dimensions in terms of who decides what AI systems can be included in education? How are these decisions made? Who can design? Who can have access to these? And who can afford these particular aspects? So these have a way in terms of impacting social and ethical challenges. And so when we're looking at the Global South, for example, think about rural areas. We have difficulties in having access and affordability because, of course, technology is not cheap. It needs funding to be developed. It needs funding in order for it to be accessible and affordable to a lot of people. And we have issues around power. So these are power outages that a lot of countries in sub-Saharan Africa are facing. For example, Zambia, South Africa, Zimbabwe all face power outages at certain times. These have an impact on how generative AI can be used in education. And so we have issues around technical skills as well and knowledge transfers that are needed in order to ensure that modern teaching with the use of generative AI can actually be effective and can be used efficiently in these developing countries. And that in itself has an impact on equality, on fairness, and also on it being inclusive and representative of diverse groups. If we're looking at one example that we can look at is the number of AI professionals worldwide, particularly when it comes to women. We have about 22% of AI professionals. Now, when you think about extrapolating this to developing countries, for example, African countries, I think the number of women is very minuscule. And when we then look at it, we streamline it to education and also the education of children, particularly comparing female students to male students. You find that the numbers are very, very limited in that respect. So then that bias kind of continues from the time that kids start their learning journey to the time that they start working in these fields. And so that in itself also helps in terms of having this AI divide. So for example, the ITU indicated that about 38% of African populations use the internet. So when we're looking at using AI in that respect, we can then kind of have a sense of what is going on in terms of having this particular or these particular technologies used in education setups in more in less developed countries. And then, of course, there are aspects related to academic integrity. So we're looking at issues around plagiarism, for example, which a lot of higher education institutions, for instance, are very much concerned about, because obviously there's concerns about students not necessarily doing their own work, but using a generative AI to actually do their work. So these are some of the ethical aspects that are concerning, but not only for the Global South, but also for the Global North as well when it comes to academic integrity. So when we kind of look at it in much more detail, we see that the AI bias does exist, especially when we're looking at social disparities, as I've already talked about. Rural areas, for example, are quite behind when it comes to generative AI in education. There is a lot of talk of having AI use in education, but without the infrastructure, for example, to ensure that these social disparities are a thing of the past, it becomes very, very impossible, particularly for rural areas, to be able to use the generative AI in education. And that is a major concern. I was carrying out AI training in Zambia back in, I think, March. And this aspect came up frequently. What happens to rural areas? We're always talking about having using AI technologies, but are we ready for these technologies, especially because we do not necessarily have the knowledge, skills, we do not necessarily understand how we can use AI to really help in terms of education and in terms of social and economic development overall. So how can we ensure that the social disparities are a thing of the past? And that is something that governments are grappling with, particularly those in less developed countries. Yes, they are having national AI strategies that are coming up, but I think there's still a long way to go when we're talking about generative AI in education. But it's not just rural areas, it can also be in urban areas. And these are concerns that we need to be looking at very, very carefully. There is also the aspect of lack of diverse data sets. At the moment, I think a lot of AI systems are trained on very limited data, and that in itself causes inadequate representation in different demographic groups, and that can be a disadvantage when we're trying to educate young people of the different kinds of things that they need to learn about globally. And that can have an impact in other domain areas such as healthcare, such as policies and so many other different aspects, because then what happens is that the data that is being trained on is quite skewed to a specific demographic. And that in itself also has an issue, has impacts on lack of cultural sensitivity when we're looking at these AI systems, because for AI to be used effectively in education, I think we need to ensure that cultural values and cultural norms are also included in these AI systems. And at the moment, I'm not really sure that this is happening to great effect. And then, of course, we've had the issues around gender disparities, which I talked about earlier when I talked about women in the AI workforce being only about 22% globally. So there are a lot of social disparities that have been discussed and inequalities in AI. So, for example, we have scholars such as Cathy O'Neill who've talked about weapons of mass destruction, algorithms of oppression by Noble. Joey Bulamini talks about coded bias or automating inequalities as well. And so these are issues that are very much happening in generative AI in education. And this can also exacerbate AI divide when we're talking about digital literacy, when we're talking about content that is relevant. And if the content is not necessarily meeting the standards of education, then it becomes excluding, particularly for a lot of young people in education. And in this case, this might be the case for the Global South as well. We need to be talking about infrastructure as well. There's a lot of issues around infrastructure in less developed countries, and also even when the infrastructure is there, the maintaining and upgrading of these infrastructures are very, very difficult. At the moment, there's a lot of issues regarding lack of funding, and so that in itself can be a disabler in terms of having an inclusive generative AI usage in education in the Global South, for instance. And then, of course, we have the aspect of plagiarism that a lot of higher education learning institutions are actually facing. But not only higher education, even primary schools, secondary schools, they're having this issue and they're grappling with policies. What sort of policies should be put in place to ensure that plagiarism is something that should be less concerning. But even as educators are grappling with this, I think the issue should not just be educators grappling with issues related to plagiarism, but they also need to look within themselves to understand how they can use artificial intelligence to help with assessment, for example. And one of the issues really is that there is no training, and there is no support in understanding the advantages that AI or generative AI systems can actually help in terms of educating, particularly in terms of assessment. Because I think there's an issue related to being comfortable in terms of how we've always educated our young people. Now, a technology such as generative AI technology or AI systems have come into place. We're kind of lost as educators, and we do not necessarily understand how we get over the concerns around plagiarism, for example, that students that can help in terms of students getting over this particular aspect. So we need to be considering some of these issues. The horse has already bolted. What do we do with this? We can't really stop students using generative AI technologies. We need to be thinking of ways of encouraging ethical, more responsible ways of using these technologies. So some of the recommendations related to transparency and accountability. I think that a lot of AI systems are not necessarily understood in terms of how they work. And this is both on the part of educators and also students, because students don't necessarily understand how they can use them responsibly, and also educators don't necessarily understand whether students are using them responsibly, and if they are not, how can educators help them to use these AI systems responsibly and transparently. And so there is need to define to ensure that these AI systems can be interpreted and used in a justified manner in educational contexts. There's the aspect of autonomy and human oversight. For the most part, I think we're at a stage where there is a lot of overreach, perhaps on the part of students. So they're kind of ceding control to the generative AI systems in terms of helping them with their work. For most of them, I guess I need to look a lot more into research in terms of the numbers or percentages that this is happening to. But I think there is need then to maintain human involvement in critical decision making to prevent AI overreach, because if we seek control to these technologies, then of course there will be major issues as we introduce these generative AI technologies, but then also even technologies to come in the future. So we need to ensure that these AI tools should provide transparent, understandable feedback to both educators and to the students that we teach. And then there's the aspect of equitable and inclusive generative AI tools, for example. We need to ensure that they address and reduce bias in AI systems, and that students can have fair access to these technologies, and that they can be able to afford these technologies. Again, looking back at the Global South perspective, a lot of these students are not able to afford these technologies. And so it becomes, I guess, redundant in a way. If they can't afford, how then do we ensure that these generative AI technologies are able to be useful in a way that can help in terms of ensuring that students are educated fairly across the board? How many minutes do I have? Right. I'll go on to the next one. And then quality and reliability. We also need to ensure that AI systems provide correct and up-to-date information. At the moment, I think there is a need to ensure that there's up-to-date information when we're using these generative AI technologies. And I think it's because what is happening at the moment is that students think that the use of, for example, ChatGPT, once they use this technology, that the information is reliable, then they stop making sure that they do their own research. So they need to be educated to understand that these tools can just be perhaps used as a guide to help them with their education, and not necessarily something that they use without necessarily looking at it critically. And I suppose this also contributes to why there is concern around plagiarism on the educators' part. So that's one of the reasons why we need to engage with these technologies as educators in order to ensure that the issue of plagiarism or cheating is avoided. And so we need to align the AI tools with clearly defined educational goals that can benefit the students as well as the educators. And I guess one of the ways of looking at it is to look at regulatory frameworks, particularly when looking. So here I'm going to be looking at, to be considering the global South. At the moment, as I indicated, there are countries that are looking at national AI strategies, but these are not necessarily being looked at in a much more clearer way, particularly when we're looking at education. So, for instance, I think there's a lot of kind of copy and paste of these national AI strategies from more developed countries, but the experiences are different, and the way students are educated and the way students can access these technologies are different. And so the policies should ensure that the experiences of students in the global South are able to reflect the needs and also what can be afforded when we're introducing these generative AI technologies. So there ought to be standards for AI use in education as well that should foster innovative solutions that are related or relatable to these particular countries or indeed setups. There's also needs to ensure that data sets for training large language models are representative and are also representative of experiences of not only countries in more developed regions of the world, but also less developed countries as well. And so we need to ensure that these technologies are indeed transparent and that they actually mitigate the current issues of education that we are kind of grappling with in the educational setup in less developed countries. So I will stop here and then let my next presenter present, and then I'll answer questions if there are any. So let's see.
Thank you very much, Kutoma. I'm just going to share my slides with you. Hopefully you can see that. Are they coming through? Great.
Yes.
So what I wanted to spend a little bit of time this afternoon or morning, depending, or evening, wherever you are in the world, also providing some additional facets of thinking about global perspectives on ethical and social impacts of generative AI. And so the few of the topics I wanted to go over was to spend a bit of time talking about some of the economic impacts of generative AI, look specifically about how that might affect the software industry as well, because that's something that's also on students' minds. Then from there, go into talk about generative AI and CS education more broadly, and then kind of do a little bit of a deeper dive on a course that we have developed over the last about 8-9 years on addressing ethics in computing, and also some work around embedded ethics in CS courses as strategies for getting students to engage more with the ethical issues in computing, and not just generative AI, but kind of more broadly as a way for them to understand the issues that are, I think Kutoma outlined very well, that are very value laden in the work that they do, even when they think they're only doing technical work, because technical work is in fact value laden work. So to spend a little bit of time talking about the economic impact of AI, there was actually a report that Goldman Sachs put out about 2 years ago now that I think was actually pretty good in terms of looking at impact of artificial intelligence. They refer to it as AI more broadly. Mostly they're looking at generative AI in terms of economic growth and what that means by industry. And one of the things they look at is in terms of different job sectors, what level of jobs would actually potentially be replaced by, or like humans would be replaced by generative AI versus cases in which humans would be augmented, and then industries where there would actually be little impact. And one of the things that they find that's particularly interesting is that roughly 2/3 of current jobs are exposed to some degree of AI automation, and the generative AI could substitute for up to 1/4 of current work. That's talking about labor displacement there, that 1/4, which is a pretty huge percentage if you think about what unemployment rates are in many parts of the world. Now, at the same time, kind of the good news that they talk about is the fact that Generally, when you have new technologies like this, worker displacement's been offset by the creation of new jobs. Now, it's still early days in generative AI to understand what those new jobs might be. If you kind of remember, maybe 2, 3 years ago, people were talking about how prompt engineer was going to be the new job. I don't think prompt engineer is going to replace 1/4 of the workforce. So while that might be a job category in itself, it'll still be interesting to see how this plays out in terms of different job impacts. Now, looking at this by sector, and this is one of the graphs from the report, it's interesting to note that, 20 years ago, if you'd asked people about the impact of AI on labor displacement, you would have gotten lots of answers that had to do with work that would be automated, say, by robotics on the factory floor, or other kinds of physical labor that could be mitigated by some sort of robotic device. And now what's interesting is if you look at the sectors that would be impacted by AI, specifically generative AI, it's mostly around knowledge work. So if you look at some of the categories on the far left, which are the areas most impacted, it's office and administrative support and the legal profession. And then you move down a couple more and you start getting into like architecture and engineering. And then you also see eventually computer and mathematical sciences show up there. Now, part of the interesting question there is how will it be affected, right? And this is probably no surprise when you think about things like Copilot and DaVinci and a bunch of other tools that exist to allow generative AI to produce code. What Goldman Sachs estimates is basically all computer and mathematical jobs, if you look at the far right of this graph, will be affected by automation, but that they will be affected in a way that AI is complementing what humans do as opposed to completely replacing what humans do. But this does behoove us to think about from the standpoint of education. These are tools that our students will definitely be using once they get out into the workforce. And so we need to think about ways that we can still provide integrity in the education they receive, while at the same time making them facile with these tools. Now, one of the ethical and economic implications of this is that in many countries right now, the United States specifically, but this is true in many places, the current economic structure actually favors job displacement. It favors automation. And what I mean by that, here's an example. Bill Gates actually might have heard of this, actually wants a robot tax. And the idea is, why would you tax robots? And he doesn't mean necessarily robots in the physical sense, but kind of in the sense of automation. And the reason for this is the labor, human labor right now has an average tax rate of about 25%, whereas software and equipment is taxed at 5%. So what this means, and this from a paper by Darren Acemoglu, who actually just recently won the Nobel Prize in economics, and some of his co-authors, the US tax system essentially encourages companies to buy machines or automation rather than adding workers. And that's just built into tax structure. And it might be a little bit weird to think about issues of ethics and technology actually being issues in which suddenly we need to think about taxes and regulation in that regard. But in fact, that's kind of what the trend is right now. And we'll talk about how that impacts sort of the high-tech labor force in just a moment. But to show you that in a graph, here's a picture. And what it shows you is in the green bar at the top is sort of the average tax rate in the United States, effective tax rate over the last few decades. And you can see for labor, it's right around 25%. And then when you look at things like software, equipment, and structures, they had a higher tax rate where if you go back sort of, in the previous century, right, in the 1990s and 1980s. But in the most recent times, they're down at around somewhere between 5 and 10%. And so when employers are looking at this and they're looking at, well, I can employ generative AI tools that make my existing programmers 20% more productive, and the tax structure then incentivizes them to not hire that 20% more of programmers. But ultimately, these are human choices. These are things that, as educators, when we talk with the broader public or when we engage more broadly in the social conversations that we have with people in industry, we need to remind them that these are human choices. And let me give you an example. And as a matter of fact, this was an example I just used yesterday. I was giving a talk up in San Francisco to a group of venture capitalists and used exactly this example. And so here's, one data point. There was a paper fairly recently, a few years back, where they looked at the impact of GitHub Copilot on the completion of various programming tasks. And so they had two groups of people, one of whom had Copilot as a generative AI tool for code, another one that did not. And what they wanted to measure was how many of the tasks were completed by the different groups and how quickly did they complete the tasks. And what they found, unsurprisingly, is that the groups that had access to Copilot completed more of the tasks, slightly more, 78% versus 70%. But the most striking difference was that the group that used Copilot actually completed the tasks 55% faster than the developers who did not have Copilot, right? That's a huge change. Now, if you think about that kind of level of savings in labor, it kind of, was not unreasonable to consider, what if you got 25% greater productivity from an engineering team, right? If you happen to work at a company as a result of generative AI tools like Copilot. What are the human decisions that get made there? Do you take on 25% more projects and features because you now have 25% more productivity across your whole development staff? Or do you hire 25% less engineers? What I just told you actually about the tax incentives actually pushes companies to hire 25% less engineers. So we have structural reasons why we would get labor displacement as a result of the regulations we have. But ultimately, these are human choices, right? And in different people I've talked to in different sectors, they're actually deciding to make these choices differently. But this is certainly going to have an impact in terms of the employability of graduates of our programs for those of us who are involved in education over the coming years. Now, how do we think about when we think about the notion of generative AI and CS education, the impacts? And I think Kutoma already referred to many of these, so I won't belabor the issues too much. But when we think about generative AI and CS education, it's already clear for many of us in the education sector that generative AI tools can solve many problems, for example, that we would give to students in CS1. There's actually been some formal analyses of these kinds of things. And so, for example, there was a paper by Denny, Kumar, and others at SIGSI a couple of years ago that evaluated Copilot on some public data sets of CS1 programming problems. They found that on the very first attempt, the generative AI could solve about half of the problems, and with a little bit of prompt engineering, it could solve another third of the problems. Informally, when I talked to colleagues at other universities, they found that when they use something like ChatGPT and feed their final exam into it, the results that they get out, ChatGPT is basically getting somewhere between an A or a B, depending on the institution and the exam. So it's actually doing very well in terms of these CS1 classes. And so, as Kutoma alluded to, there are significant worries about generative AI for cheating and unpermitted aid. And I think one of the studies is actually that's not as well known, but really kind of puts a fine point on it, is there was a study done by Perry and others who were actually researchers in computer security a couple years ago. And what they looked at was, when people use generative AI, are they writing less secure code? And so they had, again, two groups of developers. One group got DaVinci, which was the particular generative AI code generation tool. Another group did not. And what they measured was three different things. They wanted to see how many of the problems each group solved, how secure the code was, and how confident they were in their code. And the interesting thing they found is that the group that had access to generative AI thought that their code was more secure, and in fact, it was less secure. So generative AI also has the possibility to lull us into a false sense of security with respect to the code that it generates, which means we need to be aware of this to think about even greater scrutiny of this code, and this potentially impacts our educational processes. So what are some of the approaches that we might take with respect to thinking about generative AI? Thinking about the notion of there's a great understanding necessary, or great focus on understanding code, and especially for testing code, something that students will do a lot when they get into industry, but is oftentimes not stressed as much in academic programs. And thinking about really being critical of the code that's generated by generative AI. And I think more and more people are finding kind of this notion of vibe coding, where you use generative AI along with your coding as you're doing it, as a way to be more productive in terms of code generation. But again, this notion of believing that your code is actually functional when you haven't taken the time to test it thoroughly is something that we will potentially see the consequences of more over time, unless we actually get a greater appreciation in the software engineering task of verifying this code. Thinking about, in terms of assessments, greater emphasis on larger projects, which are harder for generative AI to be able to solve a larger project, as opposed to just, smaller bits of code that are getting written. Of course, this is going to be a challenge as AI becomes more powerful and can solve larger problems. And also one thing, many of my colleagues have been looking into is how can we give more creative or open-ended components in assessment. But for folks who teach large intro CS classes like we do, where the classes can have, upward of 500 students in them, having open-ended projects becomes very difficult from assessment standpoint. As Kutoma alluded to, this is an opportunity where we could potentially use AI as a mechanism to be able to grade student assignments, or at least give us some guidance on student assignments, so there might be more scalability there. But these are some things that are critical to think about as generative AI becomes more of a tool that gets used in the software generation process. Now, we think about current progress, and I don't need to tell this crowd this, right? There's currently no consensus in higher education about how generative AI should get used, not only in CS education, but kind of more broadly across the board. There are still, folks who want to ban the use of generative AI in many classes, give controlled context for exams. I think that's kind of the most immediate reaction until there's an opportunity to figure out, more robust ways to incorporate generative AI into a class. But there are people on the other end of the spectrum that are actually embracing generative AI as a tool, even in the very first CS course. So, for example, Porter and Zingaro had a recent textbook on learning AI-assisted Python programming, where they say, look, this is going to be the way software development's done. We should teach the students from the outset. But again, no general consensus on this. It's a fluid area that's evolving. But I think most of us believe that banning the use of generative AI is going to be a losing proposition in the long term, both from the standpoint that students will use it anyway, and it's something that they will eventually need to be facile with as software engineers after they graduate. As we also know, academia can be slow to change, and this decision-making is often driven by individual instructors, not institutional mandates. That's certainly true at Stanford, where I'm at. I'm on a committee that sort of looks at generative AI across the university, as well as looking how I use it in my own classes. And there is no institutional mandate for how it should be used. It's left up to the instructor. So I think one of the critical questions in education right now is, what is the right time or venue? What is the right way to incorporate generative AI into the CS curriculum? It's not a matter of if, it's a matter of when and where. And so these are some of the interesting questions that come up. And there's been some papers, for example, that have looked at, for novice programmers, generative AI actually being a way to get them more excited about computer science and allowing them to finish more tasks. So perhaps there's an argument for actually doing this earlier in the pipeline as a way to engage students, show them the power of generative AI, but also to increase their excitement about the field if retention is an issue. So with that said, I want to spend a little bit of time going specifically into some of the ways in which we try to teach ethics to our students, and starting off with a multidisciplinary course on addressing ethics, which I think is, we've seen over time some other people, emulating a similar model. And the basic idea here is this was a course that was done in collaboration with two colleagues, Rob Reich, who's actually a moral philosopher, and Jeremy Weinstein, who's an expert in public policy, recently just became the dean of the Harvard Kennedy Business School, the Kennedy School of Government. And I, as the technologist, and what we were trying to do was bring different lenses to the understanding of ethical issues in technology. Clearly, there's what the technology itself affords. There are policy issues around how it might potentially be regulated, what regulation might exist now, and where regulation doesn't exist. And then the philosophical lens, which is to look at what are the value trade-offs involved. And if people don't think about the fact that there's value trade-offs involved in the technology they're building, it means, in fact, they are building technology that invariably has values in it without even understanding what those values are or how they're making that trade-off. And that's something we want students to explicitly understand. So the structure of the course is there are several different units or themes. Generative AI is one of them, but in very much the same vein, kind of algorithmic decision-making and machine learning for processes that make important decisions about people's lives, thinking about issues of data privacy, and then ultimately thinking about, what is the political economy of the tech sector? How do we think about certain drivers of decisions that are made based on the way the political economy is structured in those domains? So they're not just technical questions. They're certainly questions of understanding economics, regulation, and policy. And so the general structure that we think about for these classes, we have a philosophical perspective, as I mentioned. What are the values at stake, and being explicit about what are the trade-offs to consider? What are the technical perspectives? So what does the technology afford in terms of what ways it might mitigate issues or exacerbate certain kinds of value trade-offs? And then the public policy perspective. What are the rights and responsibilities of the stakeholders? What do we want the technology to actually achieve? And how might regulation be able to do that in an otherwise unfettered market? We also bring in external practitioners, policy or panels of policymakers, practitioners, academics, and ultimately the idea is to synthesize these things to be able to adjudicate value trade-offs in a meaningful way. After we taught this class for about 5 years, we wanted to bring this to a broader audience. So we ended up writing a book that I'll just briefly mention. It's called System Error, Where Big Tech Went Wrong and How We Can Reboot. But basically took a lot of the themes and ideas in our class, put them into a digestible form for the general population, because when we think of stakeholders involved in technology, it's not just producers of technology, it's consumers of technology as well. And so they need to understand what sorts of value trade-offs they are making when they decide to consume particular technologies. And that's what this book is about. The final thing I wanted to spend a little bit of time talking about was thinking about embedded ethics, which is actually a program that was started at Harvard. And I want to give a big shout out here to Barbara Gross, who's the intellectual leader of that effort. But the idea here was that if you really want students to engage with ethics, it's not sufficient to just relegate it to a separate class. You want to take these ideas and show them in context in computer science classes over and over so that students understand that this is part of what it means to be a facile computer scientist, is grappling with issues of ethics and value trade-offs. And so this initiative started at Harvard, as I mentioned, has grown to many other universities. And at Stanford, in terms of our particular instantiation, it's actually a partnership between, we have an Institute for Human-Centered AI, our Ethics Center, which is actually mostly driven by philosophers, and our computer science department. So it really is a multidisciplinary effort. We now have embedded ethics modules in 15 computer science courses that are taught by 22 faculty members, because some courses are taught by multiple faculty members or pair taught. And so the idea is that students will see these topics and various concepts related to ethics in multiple courses throughout their entire undergraduate degree, including we have 6 required core courses. 5 of those 6 courses have these modules in them. And every quarter, we have thousands of students enrolled in classes with embedded ethics. So we're, in some sense, guaranteeing that they see these issues and seeing them in the context of the classes that they're in. To give you an example of some of these modules and what we hope that students get out of them is to be able to spot what the ethical issues are, to be able to recognize the values and the design choices in building software, and to really develop a language that's about moral choices. It's not just a technical language, but also brings in the philosophical lens and the policy lens to be able to understand their responsibilities in a broader sense as software engineers or members of the tech industry. And on the right-hand side of this slide, I just show you, for example, examples of some of the modules that we have on thinking about bias and fairness that Kutoma also alluded to, but thinking about how, for example, issues of privacy and surveillance, where do you have data control and consent? Do you have participatory design? How is power being concentrated in the hands of people who design algorithms? And so very simple concepts that are powerful in context. So when you talk about, for example, bias and fairness in an algorithms class where you talk about, okay, let's do a shortest path algorithm where now we're truck drivers for Amazon and we're trying to optimize path based on revenue generated, you quickly find that where those trucks spend most of their time is in affluent neighborhoods, and that in neighborhoods that don't spend as much money or that don't really have as much money actually get starved for resources. Right. And that's based on a choice for an objective function of an optimization of a path planning algorithm. So it's very much in context of the computer science these students see. The process of how we actually build these modules is we have a team. We generally have a postdoc who comes generally more often from the philosophy side than the CS side, who's paired with a teaching assistant who's a CS graduate student to help develop the module in conjunction with the faculty instructor. And so before the quarter, they share their learning objectives. The fellow meets with the instructor in a brief meeting that, to talk about what they want to accomplish. And then there's regular check-ins through the course to make sure that the content is actually deeply embedded in the class, and importantly has an assignment or exam content associated with it so that students actually have an incentive to understand and learn that material. It's not just a bolt-on, it actually becomes part of an assignment. I'll show you an example of how we do this in our CS1 course, just to make it clear. We have an assignment called Infinite Story, which actually is an adventure game that makes calls to OpenAI's API to be able to generate scenes in that story. That's why it's infinite, because you can always call OpenAI to generate more scenes for you. And so what we ask the students is we give them a story that's about software engineers and have OpenAI generate the scenes. And then we ask them questions about, What were the names of the software engineers? What did that represent in terms of what does generative AI think a prototypical software engineer is? How do you feel about that? What does that actually mean in terms of inclusivity in the field? Right. And we tell them there's no wrong answer here, but we want you to think about these things because as people engage with generative AI on a daily basis, this is the kind of bias that actually exists. And unless you take a moment to think critically about it, it's easy to gloss over. So our real long-term ambition here is to really cultivate, support, and sustain an understanding of ethics and social responsibility in technologists, and that really means thinking multidisciplinarily. These are not just engineering problems, and so they will not just have engineering solutions. It requires an understanding of the humanities and social sciences as well. And really what we hope for is to lay a groundwork for what we think of as a fourth generation in the software development process. And what do I mean by that? What I mean is in the early days of software development, people hacked code, and at some point people realized that testing and quality assurance was necessary for building high quality products. And so all, reasonable software houses have QA teams that test software. Then a few years later, people realized usability, user testing was really critical to successful software. So what did they do? They built teams that did like UI, UX, design of software. And now all reasonable software houses do that as part of the software development process. What we saw, especially in the advent of the World Wide Web, was suddenly security became a big issue because there could be data breaches if you were interacting with software over a network. And so most software houses created places where they have security audits and red teaming and all kinds of ways to be able to look at security issues in their software. And that became a function of the software development process. And the fourth generation we think of is ethical and social considerations, that when products get built, there is actually part of the function of doing that software development is having people who think about the alignment of values and the impact of the social consequences of that software. And that becomes intrinsic in the design and deployment of that software. So with that said, thank you for your attention. And I think we're going to open it up to questions. So I will stop sharing my screen with you.
We thank you both so much. That was incredible. And so many questions came in. I kept watching the clock. I know we're all on the back end trying to determine which questions we would bring to you all. And thank you from the audience, all of you, for upvoting on the questions that are here from the two presentations we heard. So I'm going to take one from Leo. The first question is, do you have any ideas to encourage students to think critically about and beyond AI answers?
I'm going to have to take a first shot at that and then turn it over to Kutoma. I think one of the things is actually that's powerful to students is pointing out places where AI makes mistakes. And so if you can actually do that, and then the question to them becomes, can you debug this code that was, for example, generated by generative AI? And what that does is two things. Suddenly it makes them more heightened of the awareness of the fact that I can't trust this code because it can generate errors. And now it gets them into a mode to think about this tool as a tool that they deal with interactively rather than just as a generation tool, but really something that if it's going to be a guide, it produces something and they need to be critical and interact with it and test it to make sure that it actually works.
Do you want me to add something? Oh, okay.
Oh, absolutely.
Yeah. Right. Okay. I think with some of my students, I've seen that there is less critical thinking. So, for example, if they're writing an essay or something like that, you can tell that they've just used ChatGPT without really looking at it critically through the references that they have produced. And some of these references are not necessarily real references. And so it becomes very important to indicate to them that these systems are not they do not necessarily give us all the answers that we need. And that's why it's very important to be very critical about your work, about thinking through without just putting in a prompt and then expecting that whatever results come out, that those are the right answers. And this is where I think the human loop comes in, and it's very important to ensure that students understand that aspect.
Thank you. Thank you both. We'll take one more, and I'm also going to let you all know, checking out the time. We do have a stop time at the top of the hour, but if anyone can stay on to answer a couple of questions, if you have just a couple of additional minutes, that would be great. So we can just take one or two more. So just giving you all the heads up, and also to the audience. But if you have a hard stop, we definitely understand that as well. So I'm going to take one more from Monica McGill. How are resources like water and power that can have major implications in the future for people being factored into ethical decision making in the usage of AI?
Well, from the folks that I've talked to in industry, I should say there's a spectrum. So some of them don't think about it at all, right? Because they don't think where their power is being generated, right? They're building applications that are on top of the way they view it is they have a level of indirection. So they don't think about, or they don't feel like they have control over the underlying system, right? They're building a layer on top of OpenAI's API. And so most of the resource consumption is on the pre-training of that OpenAI model, not necessarily on what they feel like they're doing by layering on top of it, or not thinking about what the inference time cost is when queries actually get sent to this API. So at one level, people are not actually considering that value trade-off. For some of the folks who are at the Metas and OpenAIs of the world, who are actually doing the training of the large language models, they do think about power consumption more from the standpoint of what it costs them rather than what it costs society in terms of power consumption and impact on climate. But because those things in a weird way actually align, right? The more power you use, the greater environmental impact, but at the same time, generally, the greater the cost. They've been trying to find ways to lower power consumption. And that includes, there's research that's done in building smaller models, but also trying to find ways in which there's more renewable energy involved in power consumption. Now, with all that said, it's still a huge area of power consumption. There are many others as well. Well, blockchain is probably even worse in terms of its power consumption. So these are things we need to make students aware of. We need to push them to think about solutions. But the truth is, a lot of people just don't, because they feel like they're a layer separated from the real power consumers.
I think for the developing world, the opposite might be the case in that, of course, there are concerns around, the power consumption, but where there is no power to consume, it becomes problematic to even be thinking about these issues, because we have in most African countries, and I think I alluded to that in the presentation, we have a lot of blackouts at certain times. So, for example, one area can go without power for 4 hours or for 3 hours. So there is that that issue. So even speaking about the importance of ensuring that power consumption is less when it comes to using technologies is almost speaking, Greek, for lack of a better term. So yeah, there are these juxtapositions that we need to consider when we're talking about these aspects in comparison to developed and developing countries. So yeah, there is a difference there.
Are you all up for one more question, or we're right at time? So we can either pause. I know that Jan was actually saying from all of these questions and comments that we're going to share these out with the audience so that we can continue dialogue and also share them with you all if you want to provide feedback. But if you're up for one more, we can take one more question. Mm-hmm. Excellent. So one, I'm going through several. I was trying to get from the highest. Let's go with Bonnie's question. So she says, I've tried the idea of having students test code generated by AI. All that happens is that they feed the code back into AI, so it generates the test cases. Debugging doesn't work either because ChatGPT and Copilot can tell them how to debug. It's very frustrating. I worry that once we are graduating students who can no longer read or trace code, we will be heading for disaster. What happens when there is no one left who can read code?
Yeah, that's very. I don't even know if there's an answer to that, because I think we're having a conversation around this. Was it 2 or so weeks, 2 or so days back with colleagues? They were very frustrated. Like, what is the answer here? They can use so many different generative AI systems, and the fear is that they're not learning anything. But then at the same time, when they go into industry, I suppose the whole it kind of plays itself out again. They do the same kind of thing. So what does it mean to educate students anymore in this era of generative AI and all these other emerging technologies, that we'll have to deal with? So the educational what education is kind of what it means is kind of changing, and it is something that a lot of academicians are very concerned about. So one of the, I suppose, ways of looking at it was perhaps maybe doing a one-to-one vivas, face-to-face vivas. This maybe can help a bit, but if students are very ready for that through use of AI, perhaps that can also be something that can be hidden during the face-to-face Viva. So really, I'm not really sure that there is an answer to that, but maybe Mehran has an answer.
Well, I think you hit on a lot of the important issues there. I think for us, right, the current reality is multimodal assessment. And so what I mean by that is we have, in our CS1 and CS2 class, we have exams that are still on paper that they're not allowed to use electronic devices. And those are a significant part of the grade. And so what we tell the students is we are assessing you on your assignments. The assignments are always harder than the exam questions. And they tend to be larger projects, so that there's something that's it's not immune to generative AI, but it's harder for generative AI to get the decomposition for a few 100-line program as opposed to little bits of code. But really what we say is, this is meant to prepare you for the exams, and that the exams is the place where you don't have access to generative AI. So you need to know this stuff yourself. And there might be classes later on in the curriculum for which we stop doing that, right? And say, okay, at this point, we believe you know enough of the basics of writing code that, the class is its final assessment might be more project-based or something like that, where you can actually use generative AI. But I think it's a matter of just being judicious about how you do your assessment. Because, why do we do assessment? It's not just because we need to give grades to students. It becomes basically a forcing function for students to learn the material, so hopefully they can perform well on the assessment. And so if you have assessments where you say, look, you just can't use generative AI here, or there's kind of restrictions on it, that's one way to still force them to be able to learn how to code, is our view. And hopefully in time we come up with better solutions, but that's what we do now.
So Shaina, I'm going to have to be the spoil sport here and say that we have gone over time, and it certainly was well worth it. Shaina had the tough problem of trying to sort through all the excellent questions from participants. But I want to thank everyone for joining us today for the webinar on ethical and societal impacts of generative AI and global perspectives. Thank you so much to Drs. Wakunuma and Sahami. Great presentations. You've triggered some great questions. Jan and ACM will make these questions posed available. And just the questions asked by the audience today, I think, lead for some excellent class material and conversations. I know a group that I lead, these will lead to some good discussions and follow-up. So thank both of you for the work that you put into that. So I encourage everybody to join us on the third webinar, which will be later this fall of 2025. Watch for the announcements of that from ACM. Also watch out for the report that will be coming out from the IDICE 2025 Working Group on Ethical and Societal Impacts on Gen AI in Higher Education. That looks, I've heard some of the reports of what they've done, and it continues with the conversations that we've had today. So once again, thank you all for joining us, and we look forward to the next one. Thank you.
Thank you. Thank you for
Thank
having
you.
me.